So, good morning everyone. So, I'm working for Linaro on Citrix on Xen on ARM. During this talk, I will explain a bit what is Xen on ARM, on explaining what is the requirements to be able to start a new guest, to have a new guest or new OS supporting on Xen on ARM, on just giving some example with FreeBSD. So, I've started to port FreeBSD last September. I will be able to show you that it's very easy to port a new guest if ARM is already supported on Xen on ARM. So, what is Xen? Xen is a type 1 hypervisor. That means that Xen is running directly on the bare metal. We support ARM27 on V8, so with virtualization extensions. We already have a bunch of hardware support, so we start support with FastModel on Versatile Express, Cortex A15. We did some port on different boards, Handle board, Allwinner A21 and 21, TI OMA 5, also on some servers. So Apply Macro Xen, it's ARM 64-bit servers, on Calcida Midway's ARM 32-bit server. And there is new ports that will be in Xen in the next few months. So, as I said, Xen is directly running on bare metal. Every operating system is a guest. So the first guest we start is DOM0. DOM0 is the main guest which has every device, which on the device and under the creation of every guest, removing every guest. So we manage the hypervisor. When we start a DOM-U, the DOM-U doesn't have any emulation, so he needs to have a paravirtualized driver. So the paravirtualized driver is used for the block, so for the hard drive, and for the network. So there is a front end, so a driver in the guest, which talks to the DOM0, who has the backend. So it's a ring buffer. So the guest will just ask the DOM0 to have some data, and DOM0 will just give the data to the guest. And to be able to say there is an event, we have some event channel. It's a Xen events to say there is a new information, so you can read the ring buffer. So the ARM architecture on ARM, so everything is described by the device tray. Device tray is a hierarchical description of the hardware. So it's explaining what is the network card, what is the memory region, what is the interruption for the interrupt. It describes also a few hardware which will be used by Xen, the general timer. The geek it's the interrupt controller on the MMU to be able to have page table. So as you can see, Xen is directly designed for ARM architecture. That means that here Xen will just get the general timer, get the interrupt controller, the MMU, and it will just hide a few hardware and just give every hardware to DOM0. So DOM0 will be as another guest running as a bare metal, but it will just see a subset of hardware. So we can hide some device like the serial port, which is used by Xen, the IUMMU, etc. So if we want to port a guest on Xen on ARM, there is few requirements. The first thing is the guest boot IBI. So I will explain quick after, so I'm just giving the requirements right now. The second thing is to have a device tray support, so to be able to describe the hardware. And we request some specific memory attributes. Of course, if you want to create a guest, you need to have PV drivers to be able to have the network on file system on hard disk. And you also need to have a copy of Xen public headers. So Xen public headers is the interface between the guest and Xen with the paravirtualized protocol. So you just need to copy this on your OS and use it. So you will be able to communicate with the other guests on DOM0 on the hypervisor. The main important file is archarm, which provides the hypercall convention. So how do you call function on mechanisms to Xen? Is the mechanism to call to ask for memory, to ask for I I don't know, to ask for everything to the hypervisor. So the guest boot API. So this is the interface to boot in a virtual machine. Without that, you won't be able to boot the guest on ARM. So we already support Linux as an image. So Linux has creating a boot protocol specifically for Linux. The first thing is that there is specific values on different registers. So R0 register will always contain 0. R1 will contain FFFFFF. R2 will contain a pointer to the device tree. So this is the address of the start of the device tree. The MMU on the data cache will be disabled. So the start will start without page tables. On the instruction cache download state, we can't say if it will be enabled or disabled. This is only the support for Linux Z-image. There is also the support for ELF, which is in progress. I think so. When I did the port for FreeBSD, I chose to use the same value as Linux Z-image, but it's not fixed on. We still need to decide for the next release of Xen if we will use the same boot API. If you want to start a secondary CPU, we use PICI. So it's a firmware interface to say I want to boot the CPU, I want to shut down the CPU, I want to suspend, to resume, etc. So we use a common protocol, and we don't need specific hardware bring up. So once you have started your guest, you need to discover the hardware. So to discover the hardware, we use device tree. Xen, when it will create a new guest, it will generate a small device tree which contain some information like the CPUs, so the number of CPUs, the memory, where is the memory, the timer, the geek, so the interrupt controller, on an hypervisor node that describe what needs to be done for Xen. So this is the device tray for Xen we use to boot a guest. So the first important thing is that we describe what is the model. So we choose to create a new machine that is called Xen VM. So we create a chosen node which contains the Linux boot tags. Here it's the different CPUs. So in this case we have two vCPUs, that is Cortex F15. This is the node to describe the PICI. So we say what is the method to call PICI, what is how to start a CPU, how to shut down a CPU. Here we describe the memory regions. So we say it starts at 800 and we have 32 megabytes of RAM. Here we describe the geek, the timer. This is the LANOS which is created for Xen. So we ask for an interrupt. So this interrupt will be used for the event channel. And the region will be used for ground tables. Ground table is a way to share memory between guests. So all these values, should be used by your OS. If your OS decides to hardcode the value, even if for now we have hardcoded the value in Xen, we should not assume that it will be true for the next release of Xen. So this can be modified, and the guest should only rely on the device tree. All the binding was decided on with, there is a working group to decide what is the core binding. So we don't choose our own binding. It was already used by some operating system. So when you have started to discover your hardware, you need to have, when you need to talk with Xen, you need to have some memory attributes, specific memory attributes. The first thing is, before calling any hypercall, so calling the hypervisor, you must enable the MMU on the data instruction cache on instruction cache. Without that, as we use cache in, as we enable caching, then when the data will be shared, we can lose data. It's an ARM requirement to have the same cache memory attributes between the hypervisor and the operating system. So we also asked for the RAM, which is used by Xen. So when you ask for an APA call, you need to give sometimes a physical address or virtual address of the guest. So this memory should be write through and write back. If it's not write through and write back, your guest can maybe crash and you will never see the data from Xen or for the guest. The next thing is, so you have the memory, you have the device tray, but you can't print anything for now because you didn't have any PV drivers. So there is two important things in the PV driver. So we can divide it with the Xen core architecture. So it's the main things used by every driver. So there is Xen store, there is the ground table on the event channel. So Xen store, it's a way to, it's like a database which contains string data to know where is living, for example, your console, what is your physical array, what is the event channel, etc. The ground table is used for sharing data, as I said earlier. And the event channel is used to send an event to the guest, or the guest send an event to DOM0 on another guest. Then when you have the Xen core architecture, you need to create device. The first device, the most important thing is to have the console. If you want to debug, if you want to see if your guest has started. So you need to create the console. Then you need to have block on network if you want to have full normal guest. So with these three drivers, you can start a guest on doing nearly everything. If you want to have graphic, you can create frame buffer drivers. But in this case, we need to recompile the QEMU. It's not on, yes? The protocol is common with x86. We don't, I think it's a bit different for block protocol, but every structure is the same. I think he's using the x86-64. So all these drivers, you don't need to rewrite the driver. You can directly use the driver available in BSD license in FreeBSD. So you just need to, you have the command code and you just need to port the FreeBSD specific things to your OS. So with the device tree, with the memory, and with Xen PV drivers, you can have a normal guest. So you can start your guest on every board supported by Xen. So you don't need to support the hardware from the board. Now, if you want to boot your guest as DOM0, you need different things. This is the schema I showed you a few minutes ago. As you see, DOM0 has all the drivers, so you don't use hardware, you don't use PV drivers. So if you directly access to the hard drive or to the network for the file system. So in this case, so as I said, it's the first guest to boot. So every device is given to DOM0, is assigned to DOM0. There is some device which is used by Xen, for example, the serial, if you want to have console in Xen. The IOMMU, if you want to support, to protect your device to, sorry, sorry, the IOMMU, if you want to support your, to give your device to DOM0 or to another guest. The timer on the geek also is used by Xen. And there is some device which choose to blacklist in Xen. For instance, on the QB board, all the UARTs use the same page. So if you give a page to DOM0, or if you give, you can only give page by page to DOM0. you can't say I want to give only this part of the page. So we choose for security issue to not give this UART for DOM0 now. So DOM0 as the other guest should use the device tree. So if you don't use the device tree on your OS, assume that the hardware, for instance, on the handle, you have the serial port, but the serial port does not exist. It will likely crash. So you need to have an OS that is able to say, to discover the hardware via the device tree. So this is the main requirements to have your OS. When I started to port FreeBSD, there was already a support for x86 PV so I didn't start from scratch. The support for ARM was still experimental. That means that most of the thing is made, but there is some missing SMP support for Cortex A15 or missing some device tree binding. So I started the port in September. I've sent a patch share a few weeks ago on the main list, so we have a support for Xen on ARM guest. It's based on a different config file. So FreeBSD, you can build FreeBSD with a different config file to say, I want these drivers for FreeBSD. But the way I choose to build FreeBSD is that you can only start FreeBSD on Xen if you compile with Xen HVM config file. So you can't say, I want to take my FreeBSD port from the handle binary and put to the Xen guest. So there is another thing is that it's the guest configuration is non-modular, so the memories are coded. Some interrupt also is hard coded. I will explain a bit later why. There is also only support for guests with 1 CPU because of some restriction of FreeBSD on ARM. But I think in the next few weeks we can have multiple vCPU support. So from the point of view of the device tree, I choose to hardcode the device tree for multiple reasons. The first reason is that, as I said earlier, I've chosen to use a specific boot protocol, the Linux boot protocol. This is not yet implemented in FreeBSD. That means that you can't start your FreeBSD without any out-of-box. So you can't have. You need to have the device tree happen to FreeBSD. The second thing is FreeBSD enumerates the different device in the device tree order. So that means if you have a device which uses interrupt before the interrupt controller is initialized, the FreeBSD will likely crash because the driver is not initialized, so it won't be able to enable the IRQ. This discussion was already made a few weeks ago on the FreeBSD mailing list. They are planning to handle in different ways the device. So they will do multiple passes on the device tree, and then I think we'll be starting to initialize the bus, then initialize the interrupt controller, then the different device. The second thing is that the bindings are different. So FreeBSD binding was created like 2 years ago, and there was no common binding between the different operating systems. So the current code of FreeBSD only handles 2 cells for the interrupts. So only the number of interrupts on the configurations. On the binding we choose for Xen, we choose to have 3 cells. The first cell is saying if the IRQ is private or shared between these CPUs. The second cell is the number of the IRQ, and the third cell is giving configurations. There is some work to standardize the binding on. As the discussion was made, we think that FreeBSD will use the same binding. So if we don't use the same binding, that means that then we'll have to support different binding. And I don't think it's the solution for the future. So that was the device tree. For the memory, the FreeBSD memory always use write back, except on the early patch table. So FreeBSD, when FreeBSD boot, use an early patch table with write through memory attribute. In this case, with the current Xen versions, it will likely fail. We are working on a patch to fix this issue. So for now, I've choose to use writeback when I start FreeBSD, but I think in Xen 4.4, so the next release, we will be able to use write-through to start the guest. The second thing is that FreeBSD on ARM, assuming that every device is map with cache disabled, there is no function to say I want to map a physical address to a virtual address with cache enabled. So I've created a new function to say I can map the memory cacheable. Otherwise, you won't be able to use any difference the PV driver, because PV driver is assuming cache enabled. The last thing is I've not yet decided what to do with FreeBSD is requesting to start at a specific physical address. So if it's not starting as a physical address, FreeBSD won't be able to start. But as I said a few minutes before, the device tree, the guest should not assume that the memory region is at this address. So I think in either FreeBSD should be able to start anywhere in the memory, or either then we'll have to deal with that on to decide where is the memory in the guest following the FreeBSD requirement. For the PV drivers, so PV drivers were already made for x86 on FreeBSD. So that means that there was not much modifications. The main modification is that FreeBSD was based on 4.2 headers. On Xen on ARM was just at the beginning, so the interface was not set in stone. We've made important changes on the interface between 2 headers. So for the drivers, that was fine because I just have to take the drivers and compile it. There was only a few issues because some place on the driver we used directly the C type instead of the Xen type. So for example, for the PFN, we directly use unsing long instead of the Y type. On ARM, we decide to use another type for the PFN. The other thing is I have added is the support for HVM console. So the current support for HVM console only support PV console. So I've added a few support for that. The last thing only was a big change of FreeBSD. It was the event channel. So the event channel was x86 specific. That means that the code was using only x86 functions. So if you want to use the same code on ARM, I had to rewrite everything. I've rewrote like most of the code, but it's still missing some feature, like being able to suspend and resume the guest, on being able to async physical IRQ to via event channel to the guest. So that's part of most of my. I did all of the job. Even with that, it's still missing some feature on FreeBSD. So first thing is be able to start with device tree out of box. So I think this feature is not only for Xen but for every platform. The second thing is to finish to uniform Xen drivers across every platform. So Xen drivers is not x86 or ARM specific. It should be used. We should be able to use the same drivers on every architecture. The second thing is to be able to support SMP guest. There is also DOM0 support, so to be able to use FreeBSD as DOM0. The last thing is stability. So I'm able to start FreeBSD, but there is still some crash few times. I need to investigate why it's crashing. So any help from the FreeBSD community is welcome. So the different OS supported by Xen is Linux, of course, FreeBSD. We started to add a port on Erica OS. It's an embedded OS, open source embedded OS. We hope to see any BSD BSD operating system supporting Xen on ARM in the next couple of months. So, this was my talk. So, as I show, it's not really difficult to port a new OS on Xen on ARM. If you have any question, you can use XenDevel for any development requests on Xen, or any question about any difficulties on how to boot your OS on Xen. You can also use XenARM. It's an IRC channel of Freenode, and every XenARM people are using this channel to talk about Xen on the different OS, so on Xen. Do you have any questions? Yes.
So Xen support in NetBSD is very good on x86. Is there anything that's being done for Xen on ARM on NetBSD? Okay.
If NetBSD already supports ARM on Xen, it should matter of 1,000 or 2,000 lines of code just to be able to say we need to the memory is here, the geek is here, and that's all. It's not difficult because everything is emulated by the hardware, so you just need to have PV support and device tray support. Sorry? I don't have a demo here, sorry. I've sent every instruction on the Xen mailing list on FreeBSD ARM mailing list also, so you should be able to start a guest on your board directly. Of course, you need to have a board which supports Xen on ARM. The most important is handle on QB board. There is a support for TI OMAP, but I didn't try it yet. And otherwise, it's like fast model on some servers like Midway or Xen. MiniOS? I think there is a port of MiniOS on ARM. I didn't try. I think it's basically able to start a guest and needs to add device tree supports. I don't know much about the part.